Um, okay, so what we're going to be doing today is looking at the analysis of a variance test. And this is a slightly different sort of test, a little bit different from the t-test. And so I hope that you've had a chance to look at the video that I uploaded, because the video gives kind of an overview of the conceptual and statistical analysis behind it, how it works, and those kinds of things. Today, I'm going to show you how to do the test using R, and then I'm going to hit on some of the conceptual pieces that I'd like you to kind of be aware of. Also, make sure, and then you'll have some homework that'll be due for Thursday. And it's just one problem. The ANOVA test is a little bit more, there's more to the analysis. There's kind of a two-step or two stages to the analysis. And so it does take a little bit more time. And so you're just gonna have to do one problem and we'll go over that. I'll kind of probably go over kind of a second practice problem from a different data set on Thursday, and then we'll go through your homework as well. So make sure that your homework is there and ready to go, especially because the analysis and the concepts behind a lot of what we're going to be doing from now on, there's a lot more to it. And so you really need to get very focused and make sure that you're keeping up on what we're doing. Okay, so what I'm going to do is I'm going to, let me share my screen again here. So I shared it to where everybody should be able to see what I'm doing here. If anybody can't see that, please go ahead and let me know. Okay, so today we're learning about the analysis of variance, and a few important things to know about the analysis of variance. So far, we looked at two different types of t-tests, the independent t-test and the dependent t-test. And the primary difference between the ANOVA test and the t-test is that an ANOVA test is for three or more groups. So the ANOVA test allows you to, well, and you could do either one group and put them through three different conditions, or you can have three separate groups that are three separate conditions, but they're all analyzing the same variable. So the analysis of variance is used when you have more than one level for your variable. And so you have more than two groups. You can do 3, 4, 5, so on and so forth. Technically, you can do an ANOVA with two groups, but anytime you just have two groups, you would always just want to use a t-test. That's the more basic sort of thing that you want to do. For our factorial analysis, which we'll get into a little bit later, you can have just two groups that are part of that analysis, and it's technically an ANOVA, but we'll worry about that a little bit later. So if you look and follow on the screen here, I've also, I uploaded this syntax to Moodle, and it's just a one-way ANOVA. And so you can download that and look at it, put it in R with me. I'm sorry, put it in your R and go along with me if you would like. And the data set that I'm going to be analyzing actually comes from your book. And so the practice data set is basically how does preschool affect language development? And the basic idea is, or the basic question is, does more hours spent in preschool, does it help in, or does it contribute to language development? So the idea is if I'm in preschool more, I mean, if I have more hours there, the idea would be that I'm socializing with other students or other children more often. I'm socializing with the caretakers there. And so does that help in terms of their language development. And then two, maybe the preschool has some kind of schooling program or some kind of education program where they're teaching something. And so I want to know, does it help to improve that? So I have three different groups, and thus anytime I have the three groups, I want to do the ANOVA test. And the three groups differ in terms of how many hours they spent in preschool per week. So my independent variable is going to be, I'm a preschool, and you can maybe even just say, you know, hours spent in preschool if you want to be a little bit more specific. And then my, and we measured language based on a language development test score. And so my dependent variable is going to be language development. So the null hypothesis obviously would state that attendance at preschool has no effect on language development. Now, what's important for the strictly ANOVA test, or the ANOVA part of this test, is that the ANOVA test is always non-directional. Okay, it cannot tell me where the biggest difference is between groups. That's going to be a second test that we'll talk about here here in a little bit. But the ANOVA in and of itself can only tell me if the groups are different or not, or if they're the same, if the groups are essentially the same or if they're different. So the ANOVA test is always a non-directional test. Thus, my hypothesis is simply attendance at preschool has an effect on language development. Okay, so let's go ahead and we'll view the data set. Remember, this data set is from your book. So we go to import data set, from text, and then I'll find that here. So it's 15, so it's chapter 15, and that's data set 1. Now I look here, make sure, so I've got my two groups, got a grouping variable and a measurement variable. That's the groups and the language score. Everything looks good. So I click import. So when I take a look at this group, notice I've got three different groups. I've got the children who spent 5 hours at preschool, the children who spent 10 hours, and the children who spent 20 hours. And then I have their score that they got and on that language assessment, language development assessment measurement. Then I can go here. I can see it down in my console if I want to as well. And it does that same sort of thing. So I've got 30 subjects here. Got their scores on language and then which group they are. So I have my grouping variable, which is obviously group, and then I have the language score there. All right. So the first thing that we'll do is we'll do kind of a basic bar graph. And the bar graph we can kind of use to kind of assess, is there going to be any real difference between these groups? So because of that, the first thing that we want to do is we want to use our tidyverse to find the different numbers or the different descriptive variables that we've looked at before. And notice this is just the same thing that we've done before. First off, I'm pretty sure I've got tidyverse. Yeah, it's selected, good. So I've got my tidyverse already loaded. And so let's just kind of review how this particular little snippet or a syntax works. So I'm going to create this new object called preschool descriptives. And I'm going to create it from this first data set, this kind of chapter 15 data set that we've been looking at. And I'm going to group that by group. So remember, I want to find the means, standard deviations, standard error, and a confidence interval. And I'm going to group them by these three groups this time. 5 hours at preschool, I think 10 hours, and then I'm at 20 hours. So I'll group it by that, and then the summary statistics that I want to use is going to be this n, the mean, standard deviation, standard error, and then the confidence interval. Okay, so this is that same kind of basic syntax snippet that we've used several times to find our descriptives. So I'm going to go ahead and just run this from my syntax. Oh, yes, Danielle.
So quick question here, or more so like clarification for everyone. When we have group by and then in parentheses we're using group, that's because it is labeled as group within the data set, correct?
Yes.
Okay.
Yes, and
So
good
for,
point.
yeah, for clarification, sometimes it may not necessarily be called group.
Right.
Okay.
Yeah, so whatever you name your grouping variable, or whatever variable has that name, that's the name you want in there. So in this case, they just happen to call it group, but it could be, you know, whatever you name that is, that's the variable you want in here.
Okay.
Good point. Any other questions so far? All right, so I'm just going to take this here, and then if you, on my Mac, if I hit Command and Return, it actually puts that right into my console and runs it for me. So you can use that for your Mac. I'm sure there's a different command that you can use on your Windows machine if you want to as well. That's kind of just a nice way to do it. And then I want to, of course, check and make sure that I got everything I wanted. So here again, I've got the groups, 10 hours at preschool, 20 hours, and 5 hours. Then I have the N number in each group, the means, standard deviations, so on and so forth. Okay. All right. So any questions there? Excuse me. Okay. So now I want to create my my ggplot, and I'm going to do kind of a no frills ggplot for the first time. And so remember, when I'm doing this kind of ggplot, I want to take that data set. So that's that preschool descriptives. Here's all my different groups, my different variables there. And then group is going to be the X, because that's the axis that's going to have those three groupings. And then Y, of course, I wanted that to be my mean. And then for the geo bar, the stat I want to use for that is called identity, and that just means I'm basically just using the number that you see for that particular mean. And then the error bar, once again, is just going to be mean minus the confidence interval. And these are the two. These are basically the minimum and maximum that I'm going to use for that error bar. So the error bar is kind of a second or a separate element that I use for this graph. So here again, the big thing, anytime I'm using this, the only things that really change here once you've done this is that X has to be whatever your grouping variable is. And that's really the only thing. And then you have to make sure to get the right descriptives data set that you've already just created. But besides that, this basically stays the same. Because as long as you're finding that mean each time, and you're calling it mean, there's no need to really do anything different there. And of course, your confidence intervals stay the same as well. So I'll go ahead and run this. Okay, so based on this graph, what does it look, what would be your first assessment of this data based on the graph?
The more hours put in to reading sorry, not reading language, the better the score is.
Say it one more time. I don't think I got that first part.
Sorry, the more hours put in into language, the higher the score will be.
The more hours put into not language, but more hours put into what? The more hours you spend at
School.
What's that? I think I heard it.
Preschool.
Preschool, yeah. So it looks like on the on the face of it, it looks like if you spend 20 hours in preschool, that overall your language score is a little bit higher. Now I'll ask one advanced question, see if anybody can get it. Which of these three groups has the most variability or error in the data?
The last one?
Which one is that?
5 hours.
5 hours, good. And how do you know that?
The space between the top.
Good. So the confidence interval, which signals a much larger variance in terms of the data set, basically tells us there's more variability in that 5 hours data. So that basically tells us that data is a little bit more variable, and the mean isn't as good of a representation as like the mean for the 20 hours group is good because there's very little variability there. Good. Okay. So we know that it looks like there's some kind of difference between the groups, but now we want to find out, is that true? So to do that, first off, we have to find and we have to load the psych library. So I'll go to my packages, and I think it should already be uploaded, but let me just go ahead and take a look. Yeah, so you want to make sure that your psych library, because you're going to need some of the formulas that are specific, or some of the commands that are specific in the psych library. You want that to make sure that's there. So you can either just click here, or you can also just run this command, library psych, and you should get that. If for some reason it's not downloaded, remember that you can go to the install command, and you can find it up in the cloud, and then it'll send it down for you. Okay, so the first thing we want to do is I'm going to check out the variables. And to do that, we must specify the dependent variables in the group. So we're going to use a slightly different command, basically, to look at the means. And this is basically comes from your book. So I'm going to do describe by, which is part of that site package. So I'll click that. And then I want to use the dependent variable is going to be language score. And then the group is going to be group. So when I click on that, it basically gives me, this is basically kind of another way to get means, standard deviations, medians, and so on and so forth for my three different groups. So this is just kind of another way to do that. Now then, to run my ANOVA, it's actually fairly simple. It's not too hard. But what's different is some of these more advanced statistics, I have to create an object that's going to hold all the information I want for this particular statistical analysis that I'm doing. So if you notice, to run the ANOVA, I take what's called the M1. So I'm going to create an object called M1. And then I'm going to take the ANOVA. AOV is the command I'm going to use. And then I'm going to do that same thing. So language score. Score. That's going to be my dependent variable. And then the group is going to be that chapter. Oh, I noticed I did it. So let me go back here. So you start off with the dependent variable, and I forgot to put in the data set first. So you start with your dependent variable. That's where you start here. And then your independent variable or your grouping variable is going to be the second one. So when I click that, oh, whoops, that's what I did wrong. Let me do that one more time. And the and then language score. Sorry, and then I use that tilde by the group. Sorry, I was looking at the wrong thing. So dependent variable first, and I use that little tilde sign, and then independent variable after that, and then data equals that chapter 15 data set that I've already been looking at. Okay, so notice that it creates this object up here, and the object is that part that's going to kind of hold on to all of, it's going to hold on to the output. So then I can't just actually click on that particular object. I've actually got to do what's called a summary command. And then the summary command is going to show me the parts that I want. So I'll do summary, and I'm going to do it of that object, summary M1. Now there's a lot of different numbers here. Now, if you remember from the mini lecture, the basic thing that we're doing with the ANOVA is we're comparing the sum of squares, comparing the sum of squares within to the sum of squares between, and then we're using that to create our mean squared, which finally gets us to our F value. So the F value, the main thing that we want from our output is this 8.799. Okay. The ANOVA test is also known as the F test. So we've looked at Z, we've looked at T, and now we're looking at F. And the F value is basically showing us the difference between the amount of variance or error between the groups compared to the amount of variance or error within each group. And the basic idea behind an ANOVA test is as the difference between your groups gets larger, in comparison to the error or variance that exists within each group, as that ratio gets larger, it shows us that there is real difference between those two groups. That's the basic way that the ANOVA test actually works. So my output here is this 8.799. And then notice that here's my p-value, and the p-value is equal to 0.00114. So that's, of course, below 0.05. And thus that shows me that it is actually, this is a significant difference. So there is a significant difference between these groups. Now, the second part we have to do is figure out what the effect size is. And to find the effect size, we're going to use what's called the eta squared. The eta squared. And the eta squared is basically going to take those sum of squares that we saw, and it's going to create a formula that compares those sum of squares to each other. So I take what's called the sum of squares of between, and the sum of squares between is going to be this 1133, the 1133. The sum of squares between is telling me how much difference there is between the groups. Thus, the between sum of squares is always going to be indicated by this group here. So I'm going to compare that to the total amount to the sum of squares total. Now the sum of squares total is not given to you in your output here. You have the sum of squares of between and the sum of squares of the residuals, or the sum of the sum of squares residuals. So to find the sum of squares total, all I have to do is add these two numbers together. So that leads me to my formula, which is going to be this sum of squares between, so 1,133, and then I'm going to divide that by the sum of squares total, which is going to be that same number, 1133, plus that second number, the sum of squares residuals, which is 1738. And then that gets me my sum of squares. I'm sorry, sum of squares. My eta squared. So that 0.394639. Right, any questions there so far? So if you look up here, here's how you write out the conclusion. And so the conclusion, as I've written it here, is the number of hours in preschool had a significant effect on language development. Then I have a comma, and then I write my F value. Then I write my 2 degrees of freedom. Notice how degrees of freedom is right here. This is the DF. So that 2 and the 27 go right up here. Then I have my F value, which is this value here, 8.799. Then I list my P value. And then finally my eta squared. If you can't, I've found eta, like that symbol for eta is actually a Greek letter. So try to see if you can find it on your Word doc. Let's see, as you're writing this down. If you can't find it, just put ETA squared or ETA2. You know, we can figure out how to find the actual symbol later. But the big thing is just as long as you show that particular effect size, that'll be the main thing that I'd like to see.
I was going to say, even if you put N2, because the eta kind of looks like a lowercase n, and I'll know what they mean.
Yeah.
Yeah.
All right. Any questions so far?
I just want to point out real quick that when you have the conclusion for the ANOVA, it's very much simplified, because in this case, when we run the ANOVA, we have the 3 or more groups. And so we're just looking to see if there's an overall difference. And so that's why it's just that one quick sentence. It's almost like you're restating what you find to be true. Like if the alternative hypothesis is supported, you would restate that in this instance. So the number of hours in preschool did have a significant effect on language development, right? You just restate that, and then you put your proof, your results, right? F, P, and eta squared. And so that's why it seems a little bit short, but I want to remind you guys that, like, when you're given a sample conclusion, make sure you try and follow that pretty specifically. Obviously, you're going to be changing out numbers and variables, some of the wording and things like that, but it should be considered almost like an equation. You kind of want to plug in and get used to that, because I've had some people give me some very interesting interpretations of conclusions, and I appreciate that, you know, you're still trying to interpret the results, but we want to make sure that for now you're kind of sticking to this as closely as possible, because once you get used to this kind of format, then it's going to be easier. Like by the end of the semester, when you guys are writing your papers, then there will be a little bit of leeway, because you'll have a better understanding and then you can kind of describe it more. I hope that makes sense and is helpful.
So when you go back to your plots, one thing to remember, so notice that on the plot, it looks like the 20-hour group had the highest level of a language development. Now the ANOVA test cannot tell us that the 20 group was the highest. The ANOVA test can only tell us that these 3 groups are different. It's the only thing it can tell us. It can't tell us which group was the largest or where did the differences between the groups actually lie. To do that, we need to do what's called a post hoc analysis or a post hoc test. It's actually fairly easy to do, but here again, the ANOVA has kind of 2 steps. The first step just tells me, are these groups the same or are they different? And so right now, all I know based on what we've done so far is that these groups are different. but I'm noticing that the 20 group seems bigger than some of these other groups. So what I want to know is, where does the specific differences between these groups actually lie? And so to do that, we want to do what's called a post hoc test. So if I want to know where is the difference between the groups, I need to use what are called these post hoc tests. And they tell us where the difference actually lies between the groups. And the particular test we're going to do is called the 2K HSD. And 2K is just another fancy word that we find in statistics, and it's actually really easy to do this test. So 2K the 2K HSD, notice how it pops right up because it's part of the basic stats package. So I click on that, and then I of course want the 2K to be ran on that object that is holding all of my data, or all of my analysis really, from the ANOVA. So I just click on that, and then notice what this gives me. So this gives me basically how much difference there is, and it compares each group to each other. So it compares the 20 hour to 10 hours, 5 hours to 10 hours, and the 5 hours to the 20 hours. And then I can look at the p-values and see that, okay, so there isn't a significant difference between 20 hours and 10 hours. Because notice how my p-value here, and that's p adjusted, is 0.194. Okay, so that's above 0.05. And then I can also hopefully see that too. Notice how these groups seem pretty close to the same. And the other thing that can tell me that these groups are probably not significantly different is there's an overlap between the two confidence intervals. Notice how the confidence intervals overlap. What that tells me is that most likely there's not as much difference here. And when I look, I find that yes, this difference, 6.2, is not enough. The lower and upper, these are my confidence intervals for that difference. These are basically just kind of single t-tests that are going to be done on each one of these, though we don't have to write down the t-score. But notice here again, in my confidence intervals, 0 lies between negative 2.49 and 15.29. So that means that there is a possibility, it's statistically possible, that there could just be no real difference between these groups. Thus, this is not significant. Now here, this gets closer, but notice I'm at 0.059. That is above the threshold, so I cannot accept those as actually statistically significant. And notice here again, when I compare 5 hours to 10 hours, notice how the confidence intervals seem to overlap. And that's going to be one more indicator that these probably aren't that different. But then when we get to 5 hours and 20 hours, notice that it's the biggest overall mean difference. So there's a difference of 15 between these two scores. Notice how my lower and upper confidence intervals do not cross 0. So it starts from negative 23 down to 0.6. So it's all on the negative side, does not, my confidence interval does not include 0. And then my p-value, my adjusted p-value technically, is of course below 0.05. And this is how we can interpret our results from our post hoc test. And then this is how we write it out. So 2K HSD post hoc test revealed that 20 hours a week of a preschool, and then I list the mean and the standard error, resulted in significantly higher levels of language development in comparison to 5 hours. And so then I list the means there. Then just like we would used to do, or I'm sorry, just like we did for the t-test, this difference, and I list the difference, then I list those two confidence intervals. So that difference is right here, the negative 15. Confidence interval is this negative 23.90. and the negative 6.10 was significant with an adjusted p-value of 0.0008. Okay. All right, so questions there? Yes, Danielle.
I just want to make sure if anybody's going to say anything, that's why I try to do it quietly. But so you guys know this is an extension of the conclusion. So when we had the first part, he has it at line 57, 58, 59 up there. That's the first part of your conclusion that has to do with the ANOVA, right? So the first sentence of your conclusion will always have to do with the ANOVA, and it will include your F value, degrees of freedom, P value, and eta squared. Okay. And then after you run the 2K post hoc test, you add that, whatever you found, you add that on to your conclusion. So it's kind of like two parts, because like James explained, when you're having, and you can see it down at the bottom of the console there, when you run 2K, you're basically running t-tests as a follow-up to see where the difference is between two groups. Then you can actually see, okay, that last one, 5 hours compared to 20 hours is actually significant. So then you note that in the conclusion. And that's also, I just wanted to say real quickly too, that's also why he started with the bar graph, because it's a visual representation. You guys can actually see visually where the differences are between each group, because when you get the ANOVA by itself, it's not telling you what the difference is specifically. And so that's why the bar graph helps, so you can actually see where those differences are. And then that helps make sense of everything as you start to run those analyses.
Right. And then it shows you which one is best. So it shows you that the 20-hour a week is best, and it looks like the 20-hour per week in preschool is best in comparison to 5 hours per week. And so it shows you that if you want to really show some improvement, it's probably best to stick with that on the 20 hours. Though 10 hours is probably going to help a little bit. The significant difference, or the significant jump, if you will, is moving from 5 to 20 hours. So it kind of zeroes in on where that difference really lies. And it shows this is where you can make more directional predictions about your data, because you can actually say, look, 20 was better. It was higher, and there's a significant difference between 20 hours a week in preschool and 5 hours a week in preschool. Yeah. Yes, Danielle.
So with the conclusion, would you like them to just write out the comparison that is significant, like you have there, versus, yes. Okay, yes. So they don't necessarily need to write out each comparison like 20 to 10 and 5 to 10, because those are not significant.
Right, no. You only have to list the ones that are significant.
So hypothetically, on a homework question or something like that, if they run the 2K test and there's another comparison that is significant, that should be included in the conclusion.
Correct.
Okay.
Yeah. Good point. Thank you.
Yeah.
All right. Any other questions? Okay. So then the rest of, excuse me, the rest of the syntax is basically, I wanted to, just like we've done before, I wanted to kind of make it to where you went on your graph from 5, 10 to 20, just because I think that it looked that way. And so this is something I explained before. We use that scale x a discrete command. And notice how when I run this here, that puts that, and I think that that just looks better. And then this kind of last little part here is, once again, this is something I really would like you to work on, is working on making your graphs look better. So try to at least add some kind of element, some kind of new element each time. So notice that one really easy one to do is to add in this labs, which is basically short for labels. So notice how I add these labels on here. I changed the color of the columns because those gray I don't think it looks as nice. And then I think when you change the size of the error bars, I think that looks a little bit better too. So try to incorporate that into what you're doing as well, because I think it just kind of looks, I think the graph looks a lot better. It's a lot more easy to understand, and we always want to keep pushing ourselves to be better at our graphs as well. All right, so questions? So you guys got it? Really? It's all good to go? No questions?
Yeah, Professor, will we be going over more of this on Thursday?
Mm-hmm.
Okay.
So what I want you to do is to practice it on your own. So your homework, I still have to add this onto Moodle, but your homework is just going to be number 6.
Okay.
So just do number 6, but I want you to do it exactly like I just did mine. So run the basic ANOVA. The homework page itself actually already shows you what your F values are and such. So you can check your work and make sure that you did it correctly. And then also run that 2K HSD post hoc test to show those differences between the group. And then you can answer, it's basically a question on if there's a preference for a size of noodles at a restaurant. And so just write it up, include the ggplot, do everything that I've done here for that homework assignment. And then on Thursday, we'll go through it together as a class. And then I can also run one more example one really quick, if just to kind of make sure we're on the same page as well with that.
Okay, cool. Thank you.
Mm-hmm. Any other questions?
I will just say, it's from chapter 15, guys.
Yeah.
So usually when we're going through it, you can tell by the data set, because he used chapter 15 data set 1. But there was a question on the last homework for the paired t-test about the chapter, so I just wanted to put that up front.
Thank you.
Yeah.
And then go ahead and let's see, if you could go ahead and write your name in the chat if you haven't yet already, just to make sure that I've got a record of you here before we go. And then that'll be it. If there's no other questions, then have a great rest of your week. Hope everybody's surviving with COVID, and we'll see everybody Thursday at 2 o'clock.